Alright, so this is going to be nothing new. It's just going to be taking the ideas that we learned and applying it to a different problem with maybe a little bit more context. So suppose that we have a certain college that currently rejects 31% of all applications. We're going to take a systematic sample of every 50th application and record whether the student was rejected or not. And this resulted in a sample size of 341 people. Alright, so things I know. I know my sample size is 341. I also need to figure out what this 31% is. So it's either going to be a P or a P hat. So remember the difference. So a P is a population proportion. P hat is a sample proportion. So where does this 31% come from? It comes from all applications. So that means that's going to be a population value for me. So that means that P is going to be 0.31. Okay, so what would be our sampling distribution? So what I want for that is for us to check the conditions to see if they hold first. So let's first talk about our sampling method. So it says they took a systematic sample of every 50th application and simply record if the student was rejected or not. Okay, so looking at that sample method, so a systematic sample, so they're taking kind of one that comes in every now and then, so there's not like a timing issue. So that should seem somewhat reasonable. Doesn't look like they're recording anything that we need to be worried about of, asking a question or anything like that in any biased way. There's not really a non-response bias here because we can easily see it's a piece of paper to see if it was rejected or not. So this should seem like a pretty good sampling method. Then we need to check to see if our n times p is at least 10. So our n is our 341. Our p is our 0.31, which turns out to be 105.71. Or what that number means is that if we sampled 341 applications, we expect about 106 of them to be rejected, because that's 31% of the applications we sampled. Then we're going to take our n times the 1 minus p. And there we're going to get 235.29. That's how many applications we would have expected to be accepted. And that is also at least 10. So then I'm going to be able to say then that our p hat will be approximately distributed normally. And then you know the mean. Our mean is p. So that's our 0.31. And then I need to find my standard deviation, which remember is the square root of p times 1 minus p over n. And I know both p and n to plug into my formula here. That we get to be 0.0250. So that will be our standard deviation up here. So let's talk about what we could expect to see using the normal curve rule, that 68, 95, 99.7 rule. So I know I'm centered at P. And then I'm going to go out 3 standard deviations in both directions. This time my standard deviation is this 0.025 that I calculated above. So I'm going to subtract off my 0.025, subtract it off again, subtract it off again, and then just add it here in our other direction. And so again, what I know is if I go 1 standard deviation out, that gets me 68%. So then I know that when sampling 341 applications, (68% of the time) we should find that between our 28.5% and our 33.5% are rejected. Now if I go out that second standard deviation, we get our 95%. So in sampling 341 applications, 95% of the time, we should find that between 26% and 36% are rejected. And finally, if we go out that third standard deviation, we should get 99.7%. So in sampling 341 applications, 99.7% of the time, we should find that between 23.5% and 38.5% are rejected. So now we have an idea what to expect when we take a sample of 341 applications. So if I were to ask you, then would it be unusual to find that 20% of the applications were rejected? Well, 20% is way down here. That's not even on my picture. So that's a very unlikely value to happen. What if I asked you about 29%? Well, that's here really close to the mean, so that's not going to be very unusual to happen. So let's do some probabilities. Let's find the probability that no more than 79 of these 341 applications are rejected. So I'm going to start by putting those same numbers here along the bottom because I haven't changed anything else in my setup here. So let's keep my numbers along the bottom. So here's 0.235, here's 0.26, 0.285, 0.335, 0.36, 0.385. Okay, so I got my start of my picture. The next thing I need to put on my picture is I need p hat. P hat is our sample proportion. So I do actually need to create that. So that's going to be our 79 out of the 341 applications. So that's going to be 0.2317. So where does that fall on my picture? It's way down here, actually a little bit to the left of our 0.2315. And no more than tells me to shade to the left of that. So here's what I already know. Again, so my answer not only is going to be smaller than a half, it's way, way, way down here. I don't have much of this picture shaded. And even using my normal curve rule idea, right, this is far off of the picture. This is a very unlikely value to happen, so I'm not going to be surprised. I'm going to get a pretty small probability here. I also know I can go straight to the table because I am shaded left and my table is shaded left. And finally, I know my z is going to be negative. -1, -2, -3. It's going to be actually a little bit even further to the left of -3. So now I can calculate my z. So we need our p hat, our 0.2317, our mean, which is our 0.31 where our graph is centered at, and our standard deviation, which we calculated to be 0.025, which is also our little increment along the bottom there. And we get a negative 3.13. Alright, so next we take that value to the table. So here it's a negative 3.13 would get me this 0.0009. And then that actually is our probability, since we are shaded to the left and the table is also shaded to the left. So then I can interpret this number. So if 31% of all applications are rejected, the probability that no more than 79 of these 341 applications are rejected. Is 0.0009, or you could say 0.09%. And so what I would do here, I have a second example of doing it. What I'd actually do is pause the video here and try this part on your own, and then see if our answer matches. So let's first see if we match on the picture. So again, same numbers along the bottom there originally. My p hat this time is the 0.3666. Put that on my picture. The at least then tells me to shade to the right. So things, again, I know. My answer is going to be smaller than 50%, because again, if I had everything to the right of this, that would be 50%. I know I'm going to have to use that 1 minus rule, because of the fact that I'm shaded right. And I know that my z is going to be positive this time, since we're to the right or above the mean. And we're going between 2 and 3 standard deviations above, so it's going to be between 2 and 3. Alright, so hopefully doing our z calculation, we get 2.26, which again is between the 2 and the 3 like I thought it should be. Took that number to my table and got my 0.9881 here. But again, that's actually the piece that's to the right. It's right to the left here. So that's this piece. So I had to do the 1 minus to get the correct probability. Right, last thing we need to do is interpret it. So we would have if 31% of all the applications are rejected, then the probability that at least 125 of our 341 applications are rejected is about 1.19% chance. Alright, so hopefully that example went well. If not, you probably have some more extra practice you can work on.